Good morning, chemistry fans. Here we go to analyze our absolute zero lab that we performed yesterday. Okay. And so hopefully you watched the film and downloaded the numbers that are on the table there. Of course, our temperature is in degrees Celsius and our pressure is in kilopascals. And what we're going to do here for your analysis before you turn in your lab is really threefold. There's three methods that we are going to use to get a good estimate of absolute value, absolute zero. And just a reminder that absolute zero is a theoretical temperature. It has not been achieved for reasons we're not going to deeply get into unless you really want to talk quantum mechanics and work levels. But the idea is absolute zero at minus 273 Celsius is really the minimal energy state that you can get molecules, atoms down to. That would be the least amount of motion and heat loss and stuff. And again, it's theoretical just because as you get colder and closer, it's just harder. It takes a whole lot of work to remove that energy and stuff from the molecule. So enough on that. So here's the idea. There's three easy, simple methods we can use, or at least two, because some of you may not have the ability for the third. The first one is just a graph, and I have a simulated graph right here. And so makes no difference to me. You can either, if you have graph paper at home, you can do it, graph it by hand and then upload to come in with the work that you do on this document math-wise. You certainly can use Excel or some other graphing type program on a computer to plug in the data and have it draw a best fit straight line for you. But the basic idea is this, and if you're using graph paper at home, make the x-axis, it's always going to be temperature, but to get the best graph on a handwritten graph on paper, you'll want that x-axis to be the longest side. You know, if it's 8 by 11 paper, do it on the 11. And you want to spread out from end to end as much of that graph paper as you can. The larger the graph is, the more it will spread out the data and give you a better line, as opposed to crunching it all together. So if you're drawing this by hand or you're plugging it into the computer, either way, it doesn't matter. Your x-axis will be the temperature line. And again, I recommend it up here in the procedure and stuff that you want to start about minus 300, since minus 273 is our theory. And our top value of pressure was 130. So you'll want to go to 130, 40, you know, probably more like 140 or something, 135. Spread out that data. And then just plot it. Plot temperature versus kilopascals. You can see your kilopascals, then your pressure is your y-axis, and it's going to start at 0. Okay. And you can put it, you know, you can run the axis on a graph. You don't have to always be over at the far left-hand side. So at, you know, at 0, start your y-axis if you want, so you can see it. But anyhow, you want to go from 0 to, again, about 140 kilopascals. We capped at 130. Oh, I should say that. Sorry for the temperature. I'm looking here. About 100 degrees on the temperature. So for temperature, go on the x-axis minus 300 to about 100. On the y-axis, go from 0 to about 140. And that should cover everything. And then you just plot your points. And it should not be surprising to you that your points are going to really jumble up here on the upper right side of the graph. We did the cold methanol, so you will get one on the negative side of the temperature scale. But they should graph up, and then if you're doing this again on paper, just take a ruler or some sort of straight edge, and you can see here they use dashed lines to show the estimated data that the line would follow until it crosses the x-axis. If you're doing a computer program, same thing. Just have it draw, put in a straight line till you cross the x-axis. But that's the idea. The first estimate is just what is the number off the graph. So whether it's a hand graph, computer generated graph, what was that? Where did it cross the x-axis? At negative what value? Okay. And that'll be our first estimate. Our second estimate will be using your algebra skills and y equals mx plus b, right? Okay. So I've laid it out here, and you'll need to show your calculations to get full credit on the lab, but take any two of the points of pressure and temperature and use your algebra, doing a subtraction, and calculate the slope, right? All right. Once you have the slope, then you can take any two of the points, plug them in, and solve for b so you know where the y-intercept is. Okay, so you'll have the slope, and you'll have any two of the x and y points. Okay. All right. So first we've done slope, then we've done y-intercept. Then using the slope and the new y-intercept, okay, and then going for having y is 0, then you're going to calculate x. Okay, so in y equals mx plus b, then you're going to have 0 equals your slope, x, plus the y-intercept b, and you're going to solve for x. And again, hopefully it's some number close to negative 273. We'll find out. Okay. Then your next deal is using a graphing calculator. Now, if you have a graphing calculator, okay, and most of you do have some sort of Texas Instrument or something like that. A lot of you do. If you have a graphing calculator, then plug in all the points. And, I'm not a big wizard on Texas Instruments or graphing calculators. I use a Hewlett-Packard that doesn't do graphing. But use the programs in there to do, I think I've heard kids talk about linear regression, whatever, but get in your graphing stuff, just get the points in there. And again, follow to the x-intercept and then write in there what that value was. Okay. If you don't have a graphing calculator, it's no big deal. Just make sure you're right in that area that I don't have a graphing calculator. Okay. If you have a good friend that you can FaceTime with or something, and they have a graphing calculator and they want to plug in the points and do the work for you and give you a number, great, don't care. The first two are absolutely required. You have to have a graph with your lab, either hand or computer generated, and above you have to show the math for the algebra. If you estimate it from a calculator, great. If you don't, you don't. And then your final part of that analysis is doing a percent error. And actually you're doing either 2 or 3. We know the actual value is minus 273. The theoretical value is minus 273. The actual or experimental value is going to be what you determine. So you're going to have up to 3 different percent errors. You're going to have a percent error for your graph, and what you determine the absolute 0 was on the graph. Where did it cross that x-intercept? That's your experimental value. Negative 273 is your accepted value. Show all your work and label it as from the graph. You absolutely are going to have a percent error from your algebra, the second estimate. And again, from the algebra is your experimental value. Negative 273 is the theoretical value. label it as algebra-based guess, and do a percent error. And then if you have an estimate from your calculator, then you'll have a third percent error. Okay. And again, label it as, here's my percent error. Show the work, you know, that the calculator value was your experimental, theoretical is minus 273, and go ahead. Then you'll write a conclusion, and conclusions, again, are always the same thing. They've been the same thing all year. What was your purpose? How'd you do in achieving your purpose? Support that with data from your analysis. Where could errors have come in? Now, I know I performed the lab, but just to estimate where you could have an error, it's not just lab procedures, it could be calculation stuff. Okay. And then wrap it all up. And that'll be due in a few days. We're hitting the end of the week, so it'll be the start of next week before we have our exam on this unit, which is coming up early next week. So make sure you're continuing to review with some of the review sheets and stuff that we've given you. Anyhow, there we go. That's the analysis. Certainly drop into an office hour if you have a question, and we will try and help you answer it. But it should be pretty straightforward as far as an analysis. Anyhow, stay safe, stay healthy, enjoy the sunshine, and we will talk to you soon, chemistry friends.